Assalamualaikum and good day everyone. In this video, I'm going to share with you Introduction to Timber Column Design. Compression member are the member that's subjected to axial compressive force. Compression member are commonly used as column in building, cord or webs in truss, and braces in frame member. The first design consideration we should look at is the effective length of the member. Table 9 Malaysian Standard provide coefficient we can use to determine our LE depending on our end condition. If you're not sure how the end condition of the column looks like, please refer to this diagram. For example, if the member is restrained at both ends, mean fixed both ends, the effective length is 0.7 times L. The second consideration is slenderness ratio, where the formula is L effective divided by I, which is radius of gyration. We can calculate I as B divided by square root 12. In Malaysian Standard Part 2, it provides guideline for slenderness ratio of member. So there are two guidelines, which is for lambda less than 180, the member carry dead and imposed load other than from wind load. And for lambda less than 250, it is affected by wind. The last consideration is determine modification factor for compression member K8. We can use table 10 or calculate from the equation obtained from Appendix D, Malaysian Standard. So the formula requires values such as permissible stress, minimum modulus of elasticity, slenderness ratio. Nu is 0.005 times with the slenderness ratio, and factor of N equal to 1.5. This is table 10. We used to get the value of K8 for compression member. Depending on our ratio of elastic modulus to compressive stress parallel to grain and the slenderness ratio, or LE over B for rectangular section, we can match the K8 value. Okay. Interpolation is allowed in case the value we obtain in between range. For members subjected to axial compression only, we calculate the applied axial compressive strength as P over A, where P is the axial compressive load divided by cross-section area. And then we compare with our permissible compressive stress. For permissible compressive stress, there will be two situations where first is where our lambda is less than 5. We multiply grade compressive stress with K1 and K2. Inclusion of modification factor of K8 is applied if our lambda is more than 5 or equal to 5. For members subjected to axial and bending, generally columns are designed so that the axial load is in line with the column. However, there are a situation that the load will be off-center and cause bending in a column in addition to the compression. This type of loading, we call it as eccentric load, and it is analyzed differently. The figure A, this is where the load located at the centroid of the member. So our moment is equal to 0. Figure B, if the load concentrated somewhere at a center line at the distance EY from the center point, we calculate mxx as P times EY. Figure C, if the load concentrated somewhere at the center lines of xx with the distance of Ex, therefore we calculate myy equal to P times Ex. If the load concentrated away from the center line as well away from center point, then we have to calculate the mxx equal to P times Ey and myy equal to P times Ex. We have to make sure that this equation is fulfilled for member subjected to axial and bending. This is related to applied and permissible bending stress plus applied and permissible compressive stress. The total should less or equal to 1.